Okay, well, welcome back. We're going to be looking at Chapter 2-4, solving equations with variables on both sides this time. Okay, so our objectives for today is to solve equations with variables on both sides and to identify equations that are identities or have no solutions. Our standard for today is A1.2.5, which is add, subtract, and multiply polynomials and divide polynomials by monomials. Okay, so the first key concept we have here is basically the steps to solving these equations. So step one, what we want to do is we want to use the distributive property to remove any grouping symbols. Okay, then use the properties of equality to clear out decimals and fractions. So we talked about that the other day about using decimals and fractions, how to clear those out so we're working with whole numbers. Step two, we want to combine like terms on each side of the equation. Remember, like terms is like m with m's, x squareds with x squareds, things like that. Step three, use properties of equality to get rid of terms on one side of the equation and get constants on the other. So we want to get the variable terms on one side, we want to get the constants to the other side. Okay, so constants are just the numbers. Okay, step four, use properties of equality to solve the variable, and then we always want to check our answer back into the original equation. Again, that's the one that's printed in your book, in your worksheet, or on the test. Okay, never into something you have changed. Okay, so got it number one here, we're going to take a look at what is the solution of 7k plus 2 equals 4k minus 10. Okay, so the first thing we talked about, we got to get like terms together. We want to clear decimals and fractions, and what you'll notice that we don't have any of that right now. So we want to combine like terms. Well, on each side there are no like terms. We got a 7k and a 2, a 4k and a 10. So now we get down to like step 3, where we want to get the constants to one side and the variables to the other. So what we're going to do is we're going to kind of plan ahead. I know that if I subtract 4k from both sides, I'm going to have a positive on this left side. Now if I subtracted 7k, this side would be negative, so we don't want to do that. And what we're going to do, just to help us out, I'm going to go ahead and I'm going to put this line right down the middle. Again, that's so we can see where we're at. Okay, so we did it on both sides of this equation. 7k minus 4k, we get 3k's left over. We still have the plus 2, and then 4k minus 4k, that cancels. Okay, that cancels to be equal to a negative 10. Don't forget this negative. That's minus 10. It's still negative 10. Okay, so now we got the variables on this side. So we got to get rid of this 2. So again, from one-step equations to 2 steps, we want to do the inverse. So we're going to subtract 2 from both sides now. So we get 3k plus 2 and then minus 2, which gives us just 3k. Okay. When we subtract 2, we have already 10, and we're taking away 2 more, which means now we're negative 12. Okay, so remember those rules of adding same signs. And then we have 3 times k. So now when we have 3 times k, we have to remember that to counteract that, we're going to divide. So we're going to divide by 3. That gives us 1k equal to a negative 4. Okay, and again, we want to check our work. And when we check our work, what we're going to do is we're going to rewrite this equation. So it's going to be 7k plus 2 equals 4k minus 10. And then we're going to substitute in for the k in parentheses, and we're going to write in the entire problem again and simplify it down. Okay, we always want to put in parentheses because we don't want to mistake this for 7 minus 4. Okay, when we have 7 times a negative 4, we get a negative 28 plus 2. I'm going to go ahead and simplify this part down as well. Negative 28, we gain 2, we have a negative 26. Okay, well, let's look at the right side. 4 times a negative 4 makes a negative 16. we're going to take away 10 more, we get a negative 26. This is why I stressed out about making sure we check our work in the first few sections, because now it's complicated. There's a lot more things going on. We have to do the check, and we have to do it by working it out, not just saying something equals something without doing it. Okay, so start by rewriting this problem, and then we start filling in the missing pieces, and then we start simplifying each side. Don't be moving things back and forth in this step. Okay, the check, you should just work it out. Okay, so we're going to go look at problem number 2. Got it, number 2. An office manager spent $650 on a new energy-saving copier that will reduce the monthly electric bill for the office from $112 to $88. And how many months will the copier pay for itself? So the first thing is we have to define a variable. So just like we've done in previous sections, we have to define a variable. So let's go with m, which is equal to the months that we're going to have the copier. Now what we have is, let's say here's the old copier. How much were we paying a month? Well, we were paying $112 per month. So there's the old copier. Well, what we're saying now is we're going to see what that's equal to when we get this new copier, which is now $88 a month, but we paid a one-time fee, which was to purchase it, which was $650. So we set up our equation that way. First, we just kind of cover this part up, and we have the new copier, covered the new copier part up, we have the old copier. We're asking when will it pay for itself, so essentially we will equal what we were paying before. Okay, so now we have to go through the steps again. So we're going to go ahead again and put this line down the middle. Got to get this variable to the other side. So I'm going to subtract 88 again because it's a smaller one and I want to stay away from negatives. So by subtracting the smaller one, this I know is going to be positive. Okay, so 112 minus 88, I'm left with 24. That's the difference. I'd be paying $24 a month in difference with this new copier. Okay, 88 minus 88 is 0, but plus 650 is 650. I want to figure out how many months, so how much, when I take 24 away from both sides, I'm going to divide by 24. I get 1m, and 650 divided by 24 comes out to be 27.083. Okay, so how many months will it take? Well, we could say about 27 months. But the thing is, if we're going to be paying this off, it's actually going to go into that 28th month. We've completed 27, but we have this change left over. So really, if we want to say when will we actually kind of pay it all off and everything and start making money off it, it would be 28 months. Okay, so make sure you understand what that decimal means. We could say it's about 27 because it's close to 27, so it might be like 27 in 2 days, but it's going to take 28 months before we really start to see that profit. Okay, so we would go ahead and we would say about 28.7. If we really want to know, go ahead and circle that. Okay, so what we're going to look into now, problem number 3. What is the solution of 2 times the quantity 5x minus 1 equals 3 times the quantity x plus 11? Okay, so now in this case we have our parentheses. So going back to that concept summary, what we said is we have to clear these grouping symbols away. So we got to take things through. Okay, so distribute property goes through. Okay, make sure you distribute all the way through. That's something we've been struggling with, is making sure we go to each term. And that's on left and right sides. Okay, we always want to distribute all the way through. So 2 times 5 gives us 10x minus 2 still equal to 3x plus 33. Okay, and again I'm going to go ahead. I haven't changed the quantity yet. All I've done is just simplified it down. Now which side do I want to take? 10x or 3x? And I want to take 3x away from both sides. Again, so I stay positive. Okay. So now I have my 3x on that side. 10x minus 3x gives me 7x minus 2. And 3x minus 3x is 0, but we got 33. Great number. Okay, we're going to add 2 to both sides now. Again, we got to get rid of this 2. We're going backwards PEMDAS now. Okay, so addition, subtraction stuff goes first. We're left with 7x because this makes 0. And then we have 33 plus 2, which is 35. Really mental math from here on out. 7 times what makes 35? Yeah, that would be 5. Divide by 7 both sides, you get 5. Okay, again, into this printed part, we want to check, which means we want to write the grouping symbols and everything. Don't start from this second line. Okay, I want you to go ahead and do the check. I want to see what you got there when you come into class. Okay, we're going to go ahead and stop there, and we'll come back and we'll look at some more problems as we go through. Okay, we'll see you later.